All right, so today we are taking on a little introduction to translations. So first I have to just introduce you to this idea of a rigid transformation. So a translation belongs to this family of rigid transformations. So with rigid transformations, we are transforming a figure, which just means that we are altering the place and position, but we're still preserving the size and shape. So we're going to move it around on a coordinate plane or not. It doesn't have to be on a coordinate plane, but regardless, once we move it around, once we alter the place and position, we still have the same size and shape. Our figure should still match. So the original figure, we call that the pre-image. Okay, that's our starting figure. And after we've applied a transformation, our resulting figure is the image, and the figures are congruent. Okay, the three rigid transformations that we're going to cover in geometry, we're going to start with the translation, and then we're going to tackle the reflection and the rotation as well. So those are the three rigid transformations, because while we alter the place and position, the figures are still congruent. All right, so starting off with the translation. So here points move the same distance in the same direction along parallel pathways. So here I'm showing you that with a pre-image and an image. So your pre-image, like I said, is the before, and then the image is the after. Okay, and what you might see also is this little apostrophe looking notation that reads as prime. So whenever I see it looks like an apostrophe, it reads as prime. So that prime notation is really meant to show us the after. What does our figure look like after a transformation has been applied? So in this particular translation, we can see how our shapes are congruent, our figures are congruent. Let me write that here. And it looks like all of our points move the same distance to the right, so they're in the same direction, along parallel pathways. All right, so we can see that triangle RAT is still congruent to triangle R prime, A prime, T prime. So the figures are congruent. And point R, for example, is moving so many units to the right, so is A, so is T. That prime notation shows us that this is the before, the pre-image, and that this is the after with the prime notation. That is the image. All right, next up is this concept of a vector. So a vector is a quantity that has both direction and magnitude, okay, or size. So we can think of magnitude as size. Okay, represented in the coordinate plane by an arrow drawn from one point to another. So here is A to right here, B. So when I name it, I'm just going to name it as vector AB. Okay, I'm going to say it like that. That's my language, vector AB. And when I write it, I write AB with what looks like a little half arrow on top. So not a full arrow, it's not a ray. This is a new notation that reads as vector AB. So we read it from the initial point to its terminal point. So the initial point, the starting point, is point A, and where the arrow leads us is point B. So the initial point here is A, and the terminal point where the arrow leads us is B. Okay, the horizontal component is simply, well, what is the horizontal change? Well, we've gone right 1, 2, 3, 4, 5, 6, and 7 units. So I'm going to put a 7 here. That means 7 units to the right. And then the vertical span is up 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 up. I put a 10 here for the vertical component. 10 units up. So then when I write my component form, I'm putting my horizontal component with my vertical. So I use these pointy brackets like that, and I pair the 7 with the 10. So again, this combines the horizontal and vertical components. All right, so again, this is our initial point. This is our terminal point, A to B. Vector A, B, little half arrow on top. The horizontal component, what's the horizontal change? 5 units right. What is the vertical component? What's the vertical change? 10 units up. So we pair it together in pointy brackets now for component form, which is 7, 10. 7 right, 10 up. All right, so next we're going to translate triangle ART using the given vector. So -3, 4. We see the pointy brackets again. So what this is telling us right here is that it's going to go 3 to the left and 4 up. So each point is going to move 3 left, 4 up. So let's start with A. 3 left, 4 up. So my new A will be right here, and I'll call it A prime. Okay, for R, 3 left, 4 up. Here's my new R, R prime. My T, 3 left, 4 up. Here's my T prime. So I'm going to take my ruler, connect my dots. And here is my translated figure. Remember that the figures are going to be congruent, right? They're identical like a cookie cutter. We've just altered the place and position. So everything has slid 3 left, 4 up. And just to show you what the vector itself is doing, let me connect a pair of T's, for example. So if I draw in an arrow from T to T prime, just like this, I'm showing that vector pathway. So I'm showing that this is my initial point, this is my terminal point. And if I draw it in for all of them, you can see how each point is sliding along that pathway into its new position. So I've just drawn in those arrows that connect the pre-image to the image points. And again, you should be seeing that these are running parallel. Those pathways are running parallel to each other. So whenever we're doing a translation, remember that our points move the same distance in the same direction along parallel pathways. Okay, at the bottom, I'm also pointing out that you can also express a translation along a vector using a translation rule instead. So let me write this as a translation rule. So any rule, we start with x, comma, y, arrow to the right. So what is it that we're changing? We're taking each x value And we're really subtracting 3, right? To get from here to here, the x value is less 3. And each y value is increasing by 4. So right here, this is an equivalent statement to what we saw over here. So using the translation rule, we're saying, well, each point is going to be 3 left, so move 3 left and 4 up. So again, this is just an equivalent structure. This is the translation rule. All right, lastly, find the component form of the vector that translates p to p prime. So let's plot those 2 points. P is at -3, 6. And p prime is at 4, -2. So right there. Okay, I'm going to draw it in. Make sure this is an arrow like that. So P to P prime. So P is my initial point, and P prime is my terminal point. So how did we move it? So I can see right here my x values are 7 apart. I can also just count over in my graph, but I know that it's moving 7 to the right. Okay, how about the y values? Well, I can see that they're 8 apart, and it's going down, so 8 down. So if I want to write that in component form, I use those pointy brackets. So 7 right, so 7 here, 8 down, -8 here. And that would be my final answer. All right, that's all I have for today. Have a good rest of your day.